Hello all, welcome to this video on connected components. First, reading out the definition. What are connected components? In graph theory, a connected component is a maximal set of nodes in an undirected graph such that there is a path from every pair of node within this set. No additional nodes from the graph can be included without breaking this condition. So, diving into deeper, what are connected components? They are nothing like islands in the graph. Islands in a graph. Simply. Every node in a group is connected to every other node. Okay. We are having an example of 1, 2, 3 here itself. So, every node is connected to other node in a group. But the group is not connected to any other nodes outside. So we'll take another group 4. Sorry, there are no directions. There should not be any directions. 5 and 6. Okay. This node in one group should not be connected to another node outside the group. Okay. That is a connected component. So this becomes one connected component and this becomes another connected component which looks like islands in a graph. Okay. Simply put, a connected component is a piece of graph where every vertex is reachable from every other vertex. Every vertex is reachable from every other vertex in that piece. Okay. In that piece only. Going forward, what is an undirected graph? A graph, reading out the definition initially. A graph can have one or more connected components. If there is only one connected component, the graph is said to be connected. If there are multiple such subsets, the graph is disconnected. So one more point we forgot to discuss in the connected components is, in this case, connected component help us see which parts of the graph are fully connected inside but disconnected from the other parts. So one more meaning of connected components is to look into which part of the graphs that are fully connected like this or this, these are fully connected inside but disconnected from other parts, but these are disconnected from outside. Okay, connected internally, disconnected from the outside. So next, coming into undirected graphs. So diving into deeper, what are undirected graphs? In an undirected graph, a connected component is a maximal group of nodes where there is a path between every pair of nodes within the group. Okay, it's nothing but a two-way street. Easy example of undirected graph is two-way street. If you can go from A to B, then you can also go from B to A. From A to B you can go, from B to A also you can go. This is undirected graph. Best example is two-way street. In an undirected graph, all connections are mutual. All connections are mutual and you move freely in either direction. We can move freely in each direction, either of the directions. Okay, all the connections are mutual. We can move freely in either of the directions, both the directions. So these are undirected graphs. These are all mutually connected and we can move freely from either one direction to another direction or the reverse, like a two-way street. So nodes 1, 2, 3 form a connected component. This is one connected component and they are all reachable from each other. Okay. As the principle of connected components, each node is reachable from the other node and are connected. These are fully connected from inside, but they are not connected with the other node of the outside component. Okay. 4, 5, 6 form another connected component. Therefore, this graph has two connected components with undirected graph. Okay. These are example. This one example determines both connected components and undirected graph. These are externally not connected but internally fully connected and are undirected graphs, so it can freely pass from one node to another in both the directions. Okay. So what are the applications of connected components? This connected components can be used in social networks. They can help identify groups of users who are directly or indirectly connected. Group of users who are directly or indirectly connected. Okay. Using the connected components, we can justify who are fully connected and who are not at all connected. Fully or not at all connected. Okay. In image processing, they are used to detect clusters of pixels. In image processing, we can detect the clusters of pixels. So we can group the connected pixels. Okay. Biological networks, they can be used to analyze clusters in protein interaction network. So in biological network, they can identify clusters in protein. Okay. Nothing but grouping similar proteins. Next, coming to network reliability. In network reliability, they help find isolated or vulnerable parts of the communication. We can identify isolated or vulnerable. If they are isolated, they are mostly vulnerable to the threats. Okay. So they can be connected to the network security. So how to find connected components? There are two algorithms, that are two traversal algorithms, that is depth first search and breadth first search. So what does depth first search do? It is like exploring a maze by going deep into one path until you can't go further. For example, 1, 2, 3, 4. So depth first will go more detail. So this is the connection. Imagine this is the connection. For the depth first search, this will explore by going deep into one path until you can't go further. First we'll go with 1, then it will go deep to next node 2 and next node 3, next 4. After 4 we cannot go deeper, so this traversal will end. This traversal will end, and then it will again come back to 1, and then it will go to next 6th node or 5th node, then it will traverse in deep first. Okay, we can keep going down one path until it ends, then backtrack and try different path. Then we'll backtrack and try a different path, either this path or this path. This is depth first, DFS. Then coming to BFS, it likes exploring layer by layer. Okay, for example, A, B, C, D, E, F. This is the connection. Breadth first will like to explore layer by layer. We will visit all the neighbors of the node before going deeper. We will visit all the neighbor of the node rather than going deeper. Okay, we will not go deeper. So breadth first will give importance to its neighbor nodes. For example, from A it will traverse to C or B, and then from B it will go to A or E, or from A to D, or from C to F. First it will give importance to neighbor nodes. Okay, point to be noted. Both are useful for finding paths, checking connectivity, solving puzzles, etc. So both these traversal algorithms are used for finding paths, use cases. These are the use cases: finding paths, checking connectivity, and solving puzzles, etc. Okay. So start traversal from any unvisited node, mark all the nodes reachable from it, repeat the next unvisited node, traverse each traversal give one connected component. This is all we have explained. These steps are based on DFS or BFS separately. So we have done this. So what is directed graph? So what we have explained as undirected path, undirected graph as a two-way street. Undirected graph is nothing but a two-way street. But whereas directed graph is it is a single-way street. Directed graph example is one-way street. Okay. If there is an arrow from A to B, you can go from A to B only, but you cannot go from B to A in the reverse direction. Okay. This is a directed graph. A to B, this is undirected or two-way. This is directed or one-way. Okay. The major difference between the two graphs. Point to be noted. So a directed graph shows which directions things can move or flow between points. So it nothing but it simply shows where things or directions or things can move or flow, okay, between points. We define strongly connected components where every vertex is reachable from every other vertex via directed paths. Okay, example of strongly connected components. Imagine A, B and C. Okay. Strongly connected components, SCC. Every vertex is reachable from every other vertex. For example, A can be reached from B. Okay. A can also reach from C. B can also be reached from A. Can also be reached from C. So every vertex is reachable from every other vertex via directed paths. We have designed a directed path. There is also a weakly connected component where direction is ignored when testing connectivity. Okay. So example similar to this example of weakly connected component is, sorry, A, B and C. These are weakly connected components where direction is ignored when testing connectivity. Okay, here the direction is ignored while testing the connectivity. So summary, connected components are clusters of connected nodes in a graph. Clusters of connected nodes in a graph, nothing but island of the graph. They help identify isolated sections or groups in a network, avoiding threats. We can avoid threats or vulnerabilities. They are foundational in graph analysis, clustering, connectivity application. Clustering, we have seen that clustering of proteins or clustering of images, also on. This can be used. Connected components can be used in clustering of proteins in healthcare, images in image processing, etc. These connected components can be widely used. Thank you.